want to give an interesting example of looking at trying to figure out a one-port network. So that would mean that in theory I should be able to find either a Thevenin or Norton equivalent. And where I have like a whole bunch of dependent sources, I'm trying to think about how does this kind of work itself out. And there's a dependent sources and a power supply. So that's sitting at 3.3 volts like a typical voltage. And so very interesting question to see what happens when I look at this representation. And what would I expect when I look at sort of the effective behavior looking into this V1 node? Okay, this should be very interesting. What's interesting about it is that these two current sources are, kind of have an interesting play to them. The V2 certainly related to what's going on locally, but this V1 related to this voltage. And then notice that what happens here is related to V2. So you get this sort of double coupling of things. If you're familiar with current conveyor circuits, this certainly has that feel where you kind of get one thing translated to one side and moves over, and then sort of has an alternate there's an alternate sort of push and pull between the two elements. This is exactly what you would see in this situation. And again, you could imagine where, for those who've looked at transistor circuits, where this would have come from and possibly where this would come from. All right, so what happens when I look into this? Well, what do I want to do? Well, the first thing I need to probably do is figure out, is there some relationship between V1 and V2? Because all of these things are coupled. And I could write that in many ways, but one of the things I notice is if I write KCL sitting at V2 pretty quickly, I get some interesting results here. One of which is I get, V2 over R1, GM2, and R and GS terms all together here. So rearranging, I get this equation where I get GS and a 1 over R1 term. Now the question is going to be, well, which one's typically bigger, which one's typically smaller? Well, we're going to use two different cases here that are probably not going to be unfamiliar if you actually do certain transistor cases, but the case is typically going to be here. This 1 over R1 is going to be a much smaller value than the GS value. So in general, the GS V2 is going to be much more of the key term. For those who are probably thinking about it a little more carefully, this probably looks like more like an output resistance of something, where this looks like a transconductance of a particular transistor. So yeah, it's probably not a shocking sort of comparison. And so if you look at this, you're going to have that your V2 is in relationship of GM2 over GS. And basically, if you look at GM2 over GS out of the numbers we have, I mean, this is basically going to give you basically a factor that's like, factor 2, factor a half, right? Because they're like really near each other. They're like factor of 2 of each other. And so then you say, okay, this is great. This is giving a relationship between V2 and V1. Well, here's an interesting thing that happens. So then I'm going to say, all right, so I can see GM V2. Well, this is really equivalent to GM1 times GM2 over GS times, or related to V2. So I can kind of get a different term out of this. Actually, it's GM1, GM2 over GS. And you're like, times V2. And you're thinking, wait, I've got a current that's proportional to the voltage that I'm applying. Ah, okay. Now I know what to do with that, right? Because after I've applied V2 straight into here, I've got V1 and a current that's proportional to it. That's better known as a resistor. So all of this makes basically this relationship just look like a resistor of this particular value of GS over GM1 times GM2. And I can just sort of evaluate that. In fact, for the various terms for GM1, I notice, or for various factors here, I can actually notice that for GM1, I get a resistor that's basically twice that, and for 10 megohm, it's roughly twice that. No problem. Notice there's no Thevenin source in this, because it's simply just a resistor in its final solution. And sometimes that happens, even though you go, but wait, there's a voltage source here. Well, yes, but that voltage source doesn't turn out to actually have any impact when you put the whole thing together. So it turns out that you get some very, very interesting circuits as you look at these opportunities.